to maintain, to extend, to test, to make sure that your code is clean, to make sure that your software design is clean, is going to be very difficult. And before we go ahead for break, one thing I want to point out, the reason why we spent a lot of time on solid principles is unless you know solid principles, you cannot apply design patterns in your program at all. All design patterns work on top of solid principles. Every design pattern that you go through, um, any kind of design pattern that you go through. If you don't do any design pattern, it's called anti-pattern. That's another way. But any design pattern you go through follows solid principle in its own way. So if you want to learn design patterns, which is highly important for a developer, please remember solid principles. All right. So with this, we'll stop here now. We'll go for our break. We'll connect ahead after the break. I hope that is fine. And yeah, it's 10:32. Let's join somewhere by 10:37 p.m. Sorry, a.m. Eastern time. Let's do that. By then, I'll give you a few more description on how you can use this with design patterns, and then
That's
we'll go
only
on back to our
5 minutes.
problem. Um, I'm sorry, Jenny.
37. You typed 37.
Oh, I am so sorry. It should be 47. Yeah, I'll just edit that up. Anyway, yeah, thank you for letting me know. Right, we'll catch up by then. Thanks a lot, guys.
Thank you.
Thank you. Hey everyone, and yeah, welcome back to the session. So let's continue ahead and let's continue from where we left off. Let's try to see how these things work out. Now, back to the previous point. First, before that, I hope you're all able to hear me properly and see the screen. Please let me know if you can.
Yeah, I can hear you.
Perfect, thanks a lot. Now, moving ahead, back to this point. So we were not able to perform this mail reader application and access it right away, mainly because we did not have access to this immediately. So instead, what I've done is just added it up, and I'm just going to send myself a mail. I just have two emails for reference. So this is my from email within which with which I'm creating this application. Uh, of course, I'm just going to delete this app password later on. It is just a temporary one for reference. That's how it's supposed to be. Yeah. So you can create your own app passwords and you can just send a mail. I'm just performing this. Again, please note we're not adding any exception handling. We're not performing any other tasks within it. It's just there to send an email, and that's pretty much it. Now, once you have this, you should be able to just receive this particular email. Let's say, for instance, this is what we have sent, and that's pretty much it. That's all there is to it. So yeah, that is how you can perform these simple operations. If you want to improve upon this, if you want to make more modifications to it, you can, of course, use additional things. Like, for example, if I don't want to create an object of mail, if I rather want to create an object of mail reader, you can do that as well. If I run this, you can take a look, there's no error. The reason there's no error is when you create a mail reader application, it's still inheriting mail. Since you're still inheriting mail, what happens here is it inherits all the properties of mail, including the constructor, which means you can call this constructor using the subclass or the derived class. So this mail is the base class, the class from which we are inheriting everything. And mail reader is the derived class to which we inherit everything. When you look at tutorials, there might be different words that we use. So mail can be either specified as base class or superclass or parent class, because that is the class from which we are inheriting. Mail reader, on the other hand, is the subclass or derived class or child class that inherits all functionality of base class. This is the whole idea. This is exactly how it works out. Now, moving ahead, let's go on to the next part of this. Now that we know this, prior to this, I'm just gonna stop sharing my screen for a few seconds because I'll just delete the um, app that I had just created so that it will no longer exist in my case. Okay, and now that it's done, I can share the screen again and we can continue ahead. All right. Now, moving on from here, the next part of this that we need to know, understand, and remember is design patterns. And again, I'll just point this out. There's a big difference between just being a developer and being a really, really good developer when it comes down to this. So the idea here is that we have something called design patterns. Um, I believe one of you had asked, if I'm not wrong, it was James who had asked for particular materials on data structures and algorithms. Similar to data structures, sorry, yeah, similar to data structures and algorithms, we have something called design patterns. These are basically, again, I'm going a level above just a Python developer because let's be honest, there's no point in just being a Python developer. To be honest, it's a huge thing when you are able to design your own software applications and work around it. For reference, so there are a lot of design patterns. These are essentially solutions to common problems that you face during software development. Um, so yeah, solutions to common problems in software design or software development, however you want to call it. And there are a lot of design patterns that you have that help perform this. Again, we're only learning Python, so I'm not going to go into this in great detail. So I'm just going to take one of it um, and just give you an understanding, just give you an idea of what we use it for and how we use it. So let's take a look at the catalog. I'm going to take the most simplest one to understand, one of the most simplest ones at least. That's called singleton. Now, here's the thing. Singleton is a design pattern that lets you ensure that a class can only have one object, not more than an object, just one object. Now you might be thinking, again, back to this, why we learned solid principle earlier. Take a look at this. Every design pattern that you read, every design pattern that you understand is built on top of some kind of solid principles. And if some design pattern violates a solid principle, you'll get to know it here. So it says this solves two problems at the same time, but it violates single responsibility principle. Now, one problem, it ensures that a class has just a single instance. You might ask, like, why single instance? I'll give you a simple example. You want to perform a database connection. In an application, whenever you want to perform database connection, okay, let me put it in this way. Let's say you have an application where you have multiple files, multiple service files. One is tts.py, one is mail.py, one is authentication.py, and so on. There's so many different applications, services that you have. And there's one file called repo.py that's going to help you connect to the database. Now, here's the thing. From this, and this, and this, and this, in order to connect to the database, each one of these will have to create an object of the repo class that you'll create. You'll end up creating a repo class which will help you connect to the database. Now, since each of these services is going to connect and create an object, what happens is after creating an object, this will have its own connection to the database because each object will have its own connection. This will create an object and have its own connection to the database. This too, this as well, this as well, and this as well. So there's going to be a lot of different connections to the database that you can have. In other words, to avoid that, if you want to have a single connection to the database and use it everywhere, you basically can use singleton. And the reason why I say this website is really good is that it gives you amazing ways to learn it, understand it, and work around it. It's something really beautiful. So this is the website that I have learned design patterns to an extent, at least in my career. And I would highly, let's say, prefer these operations constantly because it's something that we get to see, we get to work on, and we get to um, work around on an everyday life around us. Right. So moving ahead, let's go on to the next case. Now here, it will ensure that because there's only one object, there's only one instance, other code will not affect it. So this is essentially what helps you. So you're going to get some real world examples, you're going to get a structure, you're going to get a pseudocode here, and then you're going to get pros and cons of it, then the coding examples of it. So one of the best ways to look at this and learn this is don't complicate it to the point that you think that it's way too complex, there's too many of them. Instead, take a look at one design pattern a day. Or if you're going for refactoring, take a look at one refactoring method a day. so that you can understand, oh, this is something that I can do in my code. This is something that I can use in my code. This is something I never thought um, we would use, but it seems to be fairly easy and simple enough. So there are a lot of things that will help you out perform this. That's a big thing that I suggest. This is where we are linking everything we learned together to work around this. Another example I want to give you as to why you need to have a singleton is, think about this. I'll give you a simple example. This is an example that we often learn as beginners when we work on singleton classes. Let's say this is a video game that you're developing. In this video game, you're going to have a scoreboard. The idea of this scoreboard is there's a single scoreboard that every player across the video game will have access to. So there'll only be one instance of scoreboard. So when you create a class called scoreboard, you're just going to make sure that this particular class scoreboard will only have one instance. So if somebody creates a scoreboard, let's say um, object, they'll get the same scoreboard. If another person creates it, they'll get the same scoreboard. So how do we apply this in real life? I'm just going to give you one example. Again, I'm not going to go through every single design pattern, but I'm just going to talk you through this one design pattern at least to begin with, so you can work around it. Anyway, this is deleted, so it should not matter. So you can replace this with anything you want. It's just going to be an app password, and you can have, let's say, some name at email.com or gmail.com for your reference. Right. Moving ahead from there, let's go on to the next part. Let's create a new file called singleton.py. We're just going to create a singleton class so that we get to understand how it works. Here's what we're going to do. I'm going to create a class called scoreboard. This particular class called scoreboard is going to have, let's say, scores of different players. And the idea is that there should be only one object of it. As simple as it sounds, there should only be one object of it. And here's what we're doing. We want to plan it in such a way that no matter how many times we create it, we get to access the same scoreboard. We get to access the same thing. I'll just take a simple example out of this. Let's start with this. Let's say we're going to create, okay, let me create it empty to begin with. Let's say we're going to create two objects out of it. The two objects we're going to create out of it are going to be, let's say, player one and player two. Once this is done, let's take player one. Oh, let's create some functions. We don't have any functions, right? So let's create a function called add score. And let's create another function called get score. I think this should be enough. Two simple functions. Now, add score is where we add a score. Let's take the object and a score. So we're just going to use self.score for that particular object plus equals score. Similarly, to get score, we'll just use the return self.score. That's pretty much it. Let's try this out. Now, if I create two objects, okay, again, let's read some. If I create two objects, if I had p1.add score of 25 and p2.add score of 50, and if I print